Hi, this is Waihan Li. Today we present the GCE-Pose, Global Context Enhancement for Category-Level Object Pose Estimation. We solve the transformation of a novel object in categories from object frame to camera frame. Category-level pose estimation faces several challenges, such as intra-class shape variation, noisy sensor point cloud input, and occluded partial observation. GCE-Pose proposed the Semantic Shape Reconstruction, a robust keypoint detector, and a global context enhancement. Compared to the state-of-the-art method that utilized the partial feature learning given the RGB-D input, our GCE-Pose additionally integrates a complete semantic geometry feature as GCE Fusion. This is the overview of our method. We have 4 different modules: a robust spatial feature extractor, a semantic shape reconstruction, a global context enhanced feature fusion module, and finally the pose and size estimator. To build robust 3D correspondences, we leverage a learnable keypoint detector to extract a subset of keypoints from the point cloud observation. To model the object efficiently and effectively, we leverage the deep linear shape model that is composed of a prototype shape, a scalar network, a deformation network, and deformation fields. And finally, we can reconstruct the object using the shape and scalar parameters given the prototype shape. To train our deep linear shape reconstruction, we separate our training into 2 stages. On stage 1, we train our method using the ground truth point cloud to get the best parameters to parameterize our shape. On the second stage, given the partial point cloud as input, we leverage the parameters obtained from the first stage as an additional supervision signal together with the transfer distance to train the network, such that given a partial observation, we can reconstruct the geometry. Then we leverage the dino feature as extractor and live it into 3D space, together with feature averaging across the instances in the category. We obtain the category-level semantic prototypes. And given the partial observation, we can then deform the category-level semantic prototype into instance-specific semantic reconstruction. Here's some visualization of our semantic shape reconstruction and different category-level semantic features. We can see that with the deep linear shape deformation, we have instance-specific geometry, while we maintain the consistency of our semantic feature across different instances in the category. To combine the information of the partial and the global information, we design a global context enhanced feature fusion module using cross-attention and positional embedding. Then we leverage the feature to get the NOCS prediction and followed by several MLP to solve the final object pose and scalar. We conduct the experiment on NOCS-REAL and HouseCat6D dataset. Here's a qualitative result on HouseCat6D dataset, and compared to the state-of-the-art method HG-Pose, our method achieves a robust performance on hard examples like the box and tubes. Here are some qualitative results on the semantic shape reconstruction module, where the input is a partial point cloud. We can reconstruct a complete semantic reconstruction. Following common evaluation matrix, we leverage the 3D IOU and degree and centimeters to benchmark our method. We also demonstrate the efficacy of the design GCE module with different geometry with and without semantic priors. In summary, we propose GCE-Pose that integrates the global context with both geometric and semantic clues for category-level pose estimation. We also introduce a semantic shape reconstruction strategy that addresses the partial observed inputs by reconstructing both geometry and semantics through learnable category deformation prototype.